This is a little revision, guys, for you for elevation, depression and bearings to help you when you're at home doing your homework. You need to remember that the angle of elevation and the angle of depression are the same angles. So if you remember back to year 8 when you did parallel lines, you will see that these two lines are parallel and this is your transverse. So when you're talking about the angle of depression, you're talking about this angle in here. When you're talking about your angle of elevation, you're talking about this angle in here. And if you remember correctly, on parallel lines, those angles are equal because they're called alternate angles. Okay, so people keep trying to do the angle of depression in here, and that's wrong. Okay, so remember that it's this one on the outside, which is the same as the angle down the bottom. Okay. Now, to solve the more complex trigonometry problems, the worded questions that we're doing, you need to visualise and draw a right angle triangle with the relevant information. Okay, it says there's a tower and there's a boat or whatever. Don't draw the tower and the boat. Just draw a right angle triangle. Make it very simple. Use a trig ratio to find your unknown, so that's SOHCAHTOA, and then check that your answer is reasonable and makes sense, and then answer your question in words. The question is written in words, so the answer must also be written in words. Here's an example of the kind of question that you would get. A helicopter is hovering at an altitude of 250 metres and the angle of elevation from the helipad to the helicopter is 35 degrees. Find the horizontal distance of the helicopter from the helipad to the nearest centimetre. Okay, so using our 5S strategy, we need to underline the key terms. So what's our question? We're going to underline that. Find the horizontal distance of the helicopter from the helipad. And then we need to circle the key information. So we've got 250 metres, we've got elevation, and we've got 35 degrees as our key thing. So if we draw ourselves a little picture, remember just a right angle triangle. Oops, not quite as straight as I would like, but anyway, there's our right angle. The helicopter's up here, hovering around, so it's 250 metres here. And it's an angle of elevation, so we're talking about the 35 degrees down here, and here's your helipad down here. Okay, so we need to find the horizontal distance. So vertical is up, horizontal is across, so we're looking for this distance here. So we need to decide what we're going to use, sine, cos or tan. What have we got? We've got our opposite. What are we looking for? We're looking for our adjacent. So which one of those SOHCAHTOA has our opposite and adjacent in it? And it will be tan. So we're going to use tan of 35 is equal to opposite, so 250 over x. And when the x is on the bottom, we're just going to swap the places of our tan and our x, and we get x is equal to 250 over tan 35. We stick that in our calculator. 250 divided by tan 35 is equal to, x is equal to 357.03, and it's asked for the nearest centimetre, so it's just 350 centimetres. So our statement would be therefore the helicopter is 357 centimetres. Oh, no, we're not talking about centimetres, we'll be talking about metres. So we need to multiply that by 100, because it did say to the nearest centimetre. Get rid of that. 35,700 centimetres from the helipad. Okay, let's have a look at them. So the angle of depression, I think that should say from the top of a 25 metre tall viewing tower. Obviously my handwriting has not come through. Let's have a look at what the actual question says. The angle of depression from the top of a 25 metre tall viewing tower to a crocodile on the ground is 62 degrees. Find the direct distance from the top of the tower to the crocodile to the nearest centimetre. So again, underlining our question, so it's find the direct distance from the top of the tower to the crocodile. I didn't make them up, I just copied them. And we're going to circle our information. So we're talking about angle of depression, 25 metre tall building, and 62 degrees. So let's draw our little triangle. Just a right angle triangle, don't be fancy. Okay, we know that it's 25 metres tall, and we know that the angle of depression, so we're talking about this angle up here, is 62 degrees. So remembering, if we're talking about this angle using our parallel lines, we're also talking about this angle down here, so it's 62 degrees as well. And we're looking for the direct distance from the top of the tower to the crocodile. So we're not talking from the base of the tower, we're actually talking from the top of the tower, so we're after our hypotenuse, this one over here. Okay, so reading the questions carefully, making sure you understand what the language is, what the words are asking you to do is very important in these worded questions. And that's why using your 5S strategies will help you. Okay, so we've got, what have we got? We've got our opposite and we're looking for our hypotenuse. So which one of our trig ratios would we use for opposite and hypotenuse? Yep, we're going to use sine. So sine 62 is equal to opposite, which is 25 over x. So once again, we have our x on the bottom. So we're going to swap the places of sine 62 and x. So x is equal to 25 over sine 62. And we stick that in our calculator. 25 divided by sine 62 equals 28.3, and we want it to the nearest centimetre. So that's 28.31 metres, and to the nearest centimetre that will be multiplied by 100, 2,831 centimetres. Okay, so we then need to write our statement. So therefore, the crocodile is is 2,000, moving things around, 2,831 centimetres from the top of the tower. Okay, let's have a look at the next one. Okay, this one's a little bit more complex. Initially, a ship and a submarine are stationary at sea level, positioned 1.78 kilometres apart. The sub then manoeuvres to position A, 45 metres directly below its starting point. In a second move, the sub dives a further 62 metres to position B. Find the angle of elevation of the ship from the sub. That's the first part. Let's underline and circle. Okay, so our question is here, find the angle. Of elevation. And here it's from the ship to the sub. Okay, so that's important as well. And our information that we're given is 178 kilometres apart. Directly below its starting point, 45 metres. Okay, and 62 metres. So it moves two times, A and then B. So let's start by drawing our diagram. So we've got our sub and our ship. So that's 1.78 kilometres. So remember, one of these is in kilometres and the other one is in metres. So you need to be careful of that. Then we're saying that the submarine moves down 45 metres directly below its starting point. So it's going down here, 45 metres. Okay, and then it says it then dives a further 62 metres. So this is A. And then it goes down another 62 metres. Okay, so here's our right angle up here. Find the angle of elevation of the ship from the sub. Let's move that one up. Most of that question's missing. Find the angle of elevation from the ship from the submarine when the submarine is at position A. Okay, so we're now looking at angle of elevation from the of the ship from the sub. So we're looking at this angle down here. Is our first angle. Okay, so we've got our opposite and we've got our adjacent, so we're going to use tan. So tan theta, we don't know what that is equal to opposite. So we have to do opposite in metres. So 1,000 metres in a kilometre, so multiply by 1,000, 1.78 times 1,000 is 1,780 over 45. And we're using theta is equal to tan of the second function of 1,780 over 45, which will give us and we do it to 2 degrees, we get 88 degrees and 33 minutes. Okay. The second part of that question is, oops, it's supposed to be down further, but it's not coming up there. Anyway, the second part of the question says, find the angle of elevation of the ship from the submarine when the submarine is at position B. So down here is position B. So we want to find this angle of elevation down here. Okay, so the same thing, only we're now got 107 instead of 45. So if we do tan theta equals 1,780 over 107, and theta is equal to 1780 divided by 170 7, sorry. Second function tan is 86 degrees and 34 minutes. We're going to round that up. 86 degrees and 34 minutes. And the third part of that question says, find the difference in the angles of elevation from the submarine to the ship when the submarine is at positions A and B. So that's just subtracting one from the other. So 88.33 minus 86.33 or 34 is going to end up being 2 degrees. So the difference is 2 degrees. Oops. Okay, and you would write those answers rather than run out of room. Okay, so now we're moving on to bearings. Remember, in maths we use true bearings when we're doing our calculations, which are given by a 3-digit number that's measured from north. So we write like 305 degrees true as our answer. There are also compass bearings, which are measured from the north-south line. So if we're talking about this is being north and this is south, so we would go, if we're doing our compass bearings, we're going north towards the east or north towards the west, and then we're going south towards the east or south towards the west. Okay, but in our compass bearings, sorry, our true bearings, we're measuring everything from our north line and going all the way around. Okay, let's have a look. The ship travels south for 5 kilometres on a bearing of 120 degrees for 11 kilometres. Find how far east the ship is from its starting point. Okay, so let's get rid of that bit. Find how far east the ship is from its starting point. So we're looking at from its starting point and how far east it is. And we've got keywords of 120 degrees and 11 kilometres, and that it's going south and for 5 kilometres. So if we draw our little compass bearing, it's going south, down this way, for 5 kilometres, and then a bearing of 120 degrees for 11 kilometres. So we've got to start our compass bearing down here again and go 120, so that's 90. 120 will be about here, and it's doing that for 11 kilometres. Okay, so the ship is down here now, and it says how far east is it from its starting point. So we're looking back, we're looking at this here. So that's our ship down there. So how far east is it? There's our right angle. We want to know this. This around here is 120 degrees. So this in here is going to be 60 degrees. So we've got an angle and we've got a side and we're looking for another side. So which one are we going to use? Sine, cos or tan? We have our opposite and our hypotenuse. We're looking for our opposite and we have our hypotenuse, so we're going to use sine. So sine of 60 degrees is equal to x over 11. So x is equal to sine 60 times 11. And our calculator will tell us that that is 9.53 to 2 decimal places, so 9.53 kilometres. Okay, that's question A. Question B, it says, find how far south the ship is from its starting point. Okay, so now we're talking about, here's the starting point up here. Let's get a different colour. Let's go green. Okay, this is our starting point up here, and we've got to go all of this distance. So it went 5 kilometres to start with, but then how far did it go after it turned and went east? Okay, so we need to be able to work out that one as well. So again, using the 11 kilometres and the 60 degrees that we have, we can do that. So we're now looking at cos. So cos of 60 is equal to adjacent over hypotenuse. So x is going to be equal to cos 60 times 11. And cos 60 times 11 is 5.5 kilometres. So the question asked how far it is south from its starting point. So we now need to add that 5.5 to our 5 kilometres and write our statement. So therefore, the ship is 10.5 kilometres from its starting position. Okay. A racing yacht sails from the start position to a floating marker on a bearing of 205.2 degrees for 2.82 kilometres, then to a finishing line on a bearing of 205.9 degrees for 101.99 kilometres. For each of the following, round to 2 decimal places. Find how far south the finishing line is. How far south the finishing line is from the start position. Let's find this question. And the second part of that question is find how far west the finishing line is from the start position, and then use Pythagoras' theorem to find the distance between the finishing line and the start position. So let's start by drawing our little diagram. So let's draw our start position, little rows, compass rows, and we're going 205.2 degrees. So 180 is straight down, so 205's out here. Let's change to green. We're going out this way, and we're going for 2.82 kilometres. Then to a finishing line. So we need another compass here. And we're going on a finishing line, which is 205.9 degrees. So that's again back out here. And they're going that for 1.99 kilometres. Okay, find how far south of the finishing line from the starting position. So here's our big. Can we do it like that? I don't think we can. Let's rub that out. Because we need to do 2 triangles because they're on different bearings. So we need to stick in a triangle here. Goodness me, moving things around. A triangle here. And then we need to stick in our triangle here as well. So we've got 2. So we want to know this one and this one, and we have to add the 2 of them together. So we know that the angle all the way around is 205.2 degrees. We know to straight down it's 180, so it's going to be 85. So 85. Let's rub that out. 180 minus 205.2 minus 180 is going to give us 25.2 degrees in here. This is also 180, and so this is going to be 25.9 degrees in here. Okay, so we've got an angle. We're looking for the adjacent, and we have the hypotenuse. So for the first one, we're going to use cos. Cos of 25.2 is equal to adjacent over hypotenuse, so 2.82. So x is equal to cos 25.2 times 2.82 And that gives us 2.55 kilometres. And then we have to do the same for the second one. So cos 25.9 is equal to x over 1.99. And x is equal to cos 25.9 times 1.99. Which is 1.79 kilometres. And so A is 1.79 plus 2.55, which gives us 4.34. And we make the statement, therefore, it's 4.34 kilometres south of the starting line. Okay, the distances, let's just put our little pictures in here. So we went out here, out here again. So we've got our triangles like this, and this one was 2.82 and this one was 1.99, and now we want to work out how far these are this way. So we said that was 25.9 and that one was 25.2. Okay, so we're now going to use sine for each of those, and again add the two of them together. So it's quite complex. It's going to take us a little while to finish this one. Sine of 25.2 is equal to opposite over hypotenuse, so x over 2.82, so x is going to be equal to sine 25.2 times 2.82, and we get times 1.20 kilometres. And then we have to do the other one, which is also sine of 25.9 is equal to x over 1.99. So x is equal to sine of 25.9 times 1.99. And we get 0.87 to 2 decimal places kilometres. And we're going to add those up. So B is equal to 1.20 plus 0.87, which is 2.07 kilometres. So therefore we are 2.07 kilometres west of the start line. And then we have to use Pythagoras' theorem to find the distance between the finishing line and the start position. So now we need a little, another little picture. Let's make him dark blue. Just using a triangle because we've got our information. So we know that we are 2.07 kilometres, and the other one was 4.34. So we're going to use Pythagoras to find this. So c squared equals a squared plus b squared, which is 2.07 squared plus 4.34 squared. 2.07 plus 4.34, which gives you 23.1205. So C is going to be equal to the square root of that, which is going to give us 4.81 kilometres to the nearest kilometre. Sorry, 2 decimal places. Okay, so there's a few examples of some of the more complicated kinds of worded questions that you can get. Like I said, it's important that you use your 5S strategies to actually handle those, underlining the questions and circling the key points, drawing your pictures, making sure your answers make sense, and then writing your statement at the end. If you have any problems, please email me or come and see me tomorrow at school. Okay.